in search of soil.
And one quote that I saw, and it's in your book, I saw it on your Instagram, blew my mind, was, though not often considered in soil assessments, fungal mycelium and the compounds they produce may be the primary source of carbon for whole soil communities. This has major implications for carbon storage strategies and for understanding system dynamics across biomes. That blew my mind when I read that, because that's something I had never thought of. A lot of people in the regenerative ag movement, it's about carbon farming, it's about carbon sequestration, one, to potentially help with climate change, but two, to also feed soils. Like, carbon-rich soils are healthier and better for the plants that we want to grow than carbon-deficient soils. Now, where's all that carbon, or where is a big source of that carbon in the soils? It's mycelium. And that, again, it blew my mind. And I think a lot of people listening to this in the farm space never would have thought of that before or had heard that before.
Yeah, I mean, there's many types of fungi in the soil. And just like the other organisms in the soil, very few of them can be cultured in the laboratory and studied under isolation. And even if they can be, what they're doing under the microscope might be relatively quite different than how they're performing in community. Still, we know that there are many types of fungi, all kinds of decomposers, some simpler molds, certainly many types and many types of ectomycorrhizal mushrooms and truffles. And that's where, and other mycorrhizal fungi in general, but especially the mushrooms and truffles, we can see and are a little bit easier to measure in some respect and genetically sequence. And that metric or that notion, I mean, that was more or less my rewriting of a similar quote out of a paper discussing mycorrhizal fungi. So that, again, it wasn't necessarily me making it up. It's sort of, I believe hopefully I have the citation there for that notion. Because when I read it, I had the same response. The way they said it, this is, and yet, it's completely ignored in all soil assessments and ecological, metrics of environmental health and soil health is, the mycelial community and the exudates, the metabolites they produce, what's their quantity, because it is so much food for the web. The notion, in short, is that the atmospheric carbon is brought into plants through photosynthesis, goes through their body and does lots of things to all the fungi that live inside of them. Every plant is a quilt of potentially trillions of fungi that are helping the plant, and those are known as endothelic fungi. Once the carbon makes its rounds, it'll go down to the root, feed its roots in the immediate rhizosphere people are familiar with. But most critically, it goes on to the mycorrhizosphere. It incorporates and interacts with the mycorrhizal fungi that are locking on to the root system. And that mycorrhizal, that mycelial network goes on and spreads vast distances and covers so much more surface area because its individual threads, or what are known as hyphae, are so much smaller in diameter relative to even the finest meristem root hair, that as they go out, their surface area, just their amount of tissue becomes carbon rich. And then as it grows, it's releasing all kinds of compounds, many of which incorporate lots of carbon. Those are released into the environment. That's how the fungus digests and lives in its environment. It releases much of its chemistry that feeds other organisms, is left behind as the fungus accumulates byproducts of digestion. So some of these compounds are digestive, some of them are protective. But a lot of waste is left behind. A lot of byproducts of the digestion is left behind as well. That includes carbon, and it makes it more accessible to other organisms and kickstarts some of the branches in the food web. But also the tissue itself, as it grows, it branches. Older branches in the network that maybe aren't really accessing nutrients well anymore will be sort of snipped off or culled internally by the fungus, and it's left behind to die off, and it becomes food for the soil. And so there's so much tissue of fungal mycelium in the soil. You've probably heard the metrics, in every cubic centimeter, there's miles of mycelium. I mean, all that tissue eventually is going to die, and it's one of the primarily translocators of atmospheric carbon into the terrestrial earth. And yes, the trees do that. They're a grand facilitator, but it's truly the mycelium that goes across hectares to spread it so much further than a single root system can. And that's the connector. I mean, and then along the way, the mycorrhizae are doing many other things that add to their ecological significance. But yeah, the carbon sinking, them being one of the major carbon sources and sinks of soil is the implications are huge. And again, you're not going to read that in many sources.
Hi, everybody. Thanks for watching. Subscribe here to get the latest from the show. Also, be sure to check out some of the great clips and watch the full interviews right here on In Search of Soil.